Everybody, we have a math competition problem that's called a short question, so I guess it's not supposed to be that much of a challenge, but I forgot to write down that m and n here are positive integers. I'll just write z plus here. Now, just a word about what we're looking for. It says we want to find out what the sum is, the smallest possible sum of m and n, given that we have two equal roots. Now, a lot of people would call this one root multiplicity 2. Two equal roots sounds a little suspicious to many. But anyway, we're looking for two equal roots. They're the same roots, okay? So we want to find the smallest possible sum of m and n. And you could anticipate more than one solution, obviously, just because of the latitude of having two variables. Now, what a lot of you are probably accustomed to seeing right here, and again, you shouldn't rely too much on the letters, but just almost it's a mainstay in this position is A, and then this is, the m is usually called B, and it's called C. I mean, it's so commonplace. I'm just going to do that because two equal roots mean the discriminant has to be equal to 0 because you would have x plus or minus 0 and some other stuff. So that would be one root or two equal roots. All right, now so again, what is the quadratic formula say? This would be your b squared minus 4ac right here. I'm just using different letters. All right, so that condition has to occur in order for there to be a single solution. All right, and this is very straightforward from here. You just move this to the other side and you get m squared is equal to this. Now, it's important at this point, probably the hardest part of the problem really is just to find out how 1492 factors. And it turns out it's equal to 2 squared times 373. 373. 2 squared times 373. Okay, and 373 is prime, folks. And that's important. If it weren't, you'd have to worry about other possible factors in here. But 373 is prime. All you have to do is check all the prime divisors less than square root of 373. So that means what, around 19, you'd have to check. You don't have to check. Yeah, you have to check everything. Let's see, 2, 3, all the way up to 19, I think, okay? And that you could confirm that 373 is prime that way, okay? So that's probably the hardest computation we're doing today. So that's prime. Now, therefore, this piece right here is going to become, you already have a 4 as part of the discriminant calculation, right? And so you would have 2 raised to the 4th power times 373, okay, times n. And so here it's clear that the smallest way to get the job done is just to put another 373 right here. So we would let n equal to 373. Yep, right, that's the best we can do. And so this would be 2 to the 4th times 373 squared. And that manifestly is a perfect square, right? Okay, that is a perfect square, clearly. And so if you take the square roots of both sides of this, you get m. Well, you get m is equal to m, right? You're going to get m is equal to m. I'll go ahead and write it out. You don't really need to, I guess. But the square root of this would be 2 squared times 373. We already know, well, we already know this is unnecessary, I suppose. Okay, it's 373. And so what do we have here? We're supposed to do the sum of m and n. So that would just be 1492 plus 373. Gosh, what is that, ladies and gentlemen? Is that equal to 1865? Another special year. Civil War year. 1865, 1492, Columbus. All right, so now you may say, wait, what's up with this? Let's check it out, and we can just see it has 2 equal roots. Well, maybe we can make some progress here. We're done with the problem right now, folks. This is the answer. But how about checking? Okay, let's see what's up with this thing. So that means for the smallest sum, you would have 1492 x squared, and then you would have 1492x. Again, folks, this isn't necessary, but just to satisfy curiosity here, plus 373, right? But we've already seen that 4 times this is 1492, so you can rewrite this as 373 times 4x squared plus 4x plus 1. All right, folks? But notice when you set this equal to 0, this part, well, I'll just write it down. Hopefully I got room. Yeah, I got it. 373 times 2x plus 1, quantity squared. Hello. Looks like a repeated root to me. Okay, so that's equal to 0, and this is squared. And so our repeated root, you know, and again, I have a little bit of problems with them calling it 2 equal roots. It's true technically, but, you know. All right, but anyway, it's a single root. Multiplicity 2 is, I think, the more common way of talking about this rather than saying 2 equal roots. I mean, I guess logically that's okay. It is a single value, and it has a multiplicity of 2. But in any event, we won't quarrel about that. The question was to find the sum, and that sum is 1865, unless I made a mistake right here. Thank you for viewing.